Hello, this is Mrs. Youd, and today we are on Chapter 9, Lesson 4. We are going to solve quadratic equations by completing the square. If you're following along in your journals, you can skip page 291 and 292, and I'm going to start today's lesson on page 293. So today we're going to do something called completing the square. Completing the square is if you have x squared plus bx, what you can do is you can add a constant, we'll call that constant c, so that x squared plus bx plus c is a perfect square. And when you complete the square, it helps you solve a quadratic equation nice and easily by using the square root that you practiced in the last lesson. So these are the steps for completing the square. We're going to take an expression x squared plus bx, and what you do to complete the square is you take this b number and you take half of it and then you square it. And you'll notice that that's what they did here, x squared plus bx, and then you add b over 2 squared. And if you do that, then what this changes into is the perfect square binomial, which helps you solve the problem nice and easily. Let's look at an example down below. So here I have the problem x squared minus 2x equals 1. So in the past, when we've tried to solve these, we would have taken the equation and we would have moved the 1 over, so that would have been x squared minus 2x minus 1 is equal to 0, and then we would try and figure out, can we factor this out? And in this case, it does not factor nicely. And so there has to be a different way to solve it when it doesn't have a nice, easily factorable thing. And completing the square that you're going to learn today is the way to do that. So how we complete the square is we want to think of a number that we can add to both sides of the equation. And remember, you have to add it to both sides in order to make the equation nice and balanced. And we want to think of something that we can add to change this left side into a nice perfect square. And the trick for that is that this number here is going to be whatever the middle number is, that b, so it's b over 2 quantity squared. So in this case we have negative 2 over 2 squared, which is negative 1 squared, which is positive 1. So if I add a 1 to both sides of the equation, then what happens on the left side is this turns into x minus 1 squared, and on the right side I have a 2. So let's just check that over on the left. X minus 1 squared is, remember, x minus 1 times x minus 1, and if I were to multiply that out, I would get x squared minus 1x minus 1x plus 1, and that turns into x squared minus 2x plus 1. And you'll notice that that is indeed the same as that we started with. And so the reason for this, the reason why we want to do this, remember, our goal is to solve for x. And so once we have a perfect square on the left side, what we can do to get rid of that square is to use the square root function like we practiced in our last lesson. And when we do that, the square and the square root cancel, and you're left with x minus 1 on the left equals plus or minus the square root of 2. So if I want to solve for x, I'm going to add 1 to both sides, and I get x is equal to 1 plus or minus the square root of 2. And this is a fine answer. However, if you wanted to find out what it was to the nearest decimal, you would need to split this up into 2 parts and use your calculator to do 1 plus the square root of 2 and 1 minus the square root of 2. So let's go ahead and do that real quick. 1 plus the square root of 2 is approximately 2.414, and 1 minus the square root of 2 is approximately negative 0.414. So these would be the answers if you were in a real-life situation and you needed to know the decimals, or if you were trying to graph it and you needed to know approximately where the x-intercepts were. All right, let's do some practice problems. In the first set of problems, it says in exercises 1 through 6, we want to complete the square for the expression and then factor the trinomial. So what they're asking us to do on this one is they're asking us to figure out what number needs to be added so that it turns into a nice perfect square. And the number that needs to be added, remember, is going to be the middle number, b over 2 quantity squared. So we're going to do 12 over 2 squared, which is 6 squared, or 36. So what we're going to be adding is 36. And when we do that, we get a perfect square binomial of x plus 6, all quantity squared. All right, let's take a look at number 2. We're going to add something so that we change this into a perfect square binomial. So we're going to add, this time, negative 14 divided by 2, all quantity squared. So that's going to be negative 7 squared, which is positive 49. So we're going to add 49 to both sides, and that changes your expression into a perfect square, which is x minus 7 squared. All right, I'd like you to go ahead and finish 3 through 6 on your own. Pause the video, turn it back on, and see how you did. All right, check and see how you did. And if you got anything wrong, please see if you can find your mistakes. In the next set of problems, we're going to solve the equation by completing the square. And they do want us to use our calculators to round our solutions to the nearest hundredth if necessary. Let's start with number 7. We're going to add something to both sides so that we complete the square. So I'm going to put plus something equals negative 15 plus something. And that something is going to be negative 8 divided by 2, all quantities squared. And that's going to be negative 4. And that means that I have 16 is what I'm going to be adding. Okay, so now this turns into a perfect square here, x minus 4 squared. And on the right side, negative 15 plus 16 is 1. So now that we have a square on this side, we can take the square root of both sides. And we are left with x minus 4 is equal to plus or minus, and the square root of 1 is 1. So now I'm going to solve for x. So x is equal to, we're going to add 4 to both sides, and we get 4 plus or minus 1. So now we're going to split this up into 2 parts, 4 plus 1 and 4 minus 1. 4 plus 1 is 5, 4 minus 1 is 3. So my answers are x is equal to 5 and 3. All right, let's do number 10. I'm going to do the same thing by adding something on both sides to make this into a nice perfect square. And what I'm going to add is going to be negative 26 divided by 2, which is 13, and the 13 squared is 169. So we're going to add 169 to both sides. So that turns this into a nice perfect square on the left, x minus 13 squared, and then the right side is going to be 160. So now we need to take the square root because we have a perfect square on the left. So we're going to take the square root of both sides, and that leaves me with x minus 13 equals plus or minus the square root of 160. So now I'm going to solve for x by adding 13 to both sides, and I get 13 plus or minus the square root of 160. So now we need to use our calculators to find out what 13 plus the square root of 160 is, and 13 minus the square root of 160. And if I use my calculators, I find out that the answers are approximately 25.65 and 0.35. And so these are my answers to the nearest hundredth. Number 13, you'll notice, is this number here is on the wrong side. So we're going to start by moving that over. So I have x squared minus 12x, and I'm going to go ahead and add my number because I know that that's coming. So -9 plus something. And the number that we're going to add is -12 divided by 2, which is 6. And then we square that, so we're adding 36 to both sides. So on the left side, we have x minus 6 squared. And on the right side, we have 27. And again, I have a perfect square, so I'm going to take my square root. That leaves me with x minus 6 on the left, and then plus or minus the square root of 27 on the right. So that leaves me with x equals 6 plus or minus the square root of 27. Using our calculators, 6 plus the square root of 27 is about 11.20, and 6 minus the square root of 27 is about 0.80. And so here are my two answers. I'm sorry that it's kind of small, but I was running out of room. Here are my two answers for number 13. I would like for you to pause the video and go ahead and work on the rest of these problems on your own. Turn the video back on when you're done and see how you did. All right, here's what I got for the rest of those problems. And pause your video and check your answers. And if you got them wrong, see if you can find your mistakes. On the next page, I'm going to skip to number 25. You don't need to worry about doing the other problems on that page. A diver jumps off of a diving board. This function represents the height in feet of the diver after X seconds. What is the maximum height above the water of the diver, and how many seconds did it take for the diver to reach the maximum height? Round your answers to the nearest hundredth. All right, so I always like to draw a picture when a picture is not given to me. So I'm going to go ahead and draw a picture of this diver. Now I know that the diver is 5 feet up in the air, so that means that the diving board is 5 feet up in the air. And so the diver is going to jump up and then they will come back down to the water. So this is when they splash into the water here. And the question is asking what is the maximum height above the water. So the question is basically asking where is the diver going to be here at the maximum height, and also how many seconds does the diver take to get there. So the seconds will be found here. This is the time is my x-axis, and the height of the diver would be my y-axis. So basically, if I just find my vertex here, I'll have my answer for everything that I need to know. One of the easiest ways to find a vertex is to go back to using -b over 2a. So if we look at our function, a is -16, b is +6, and c is 5. So if we plug in these numbers, we're going to get my b number is 6, over 2 times a, which is -16. So that gives me -6 over -32. And if I simplify that, I get +3 over 16. Using a calculator, I find that 3 over 16 is 0.1875. And that is how much time it takes. That's my seconds. That's the number that goes here, 0.1875, or about 0.19 seconds. Okay, so then now that we have that number, we can substitute in either the fraction or the decimal back into the original equation above and solve for h, and that will give us our height. So our height is -16, and I'm just going to leave the fraction in there, times 3 over 16 squared, plus 6 times 3 over 16 plus 5. And if I simplify that, I'll get my answer. And for my answer, I got 5 and 9 over 16ths, or decimal form, that would have been 5.5625. So that is the height of the diver. Okay, so now I'm ready for my final answer. The diver reaches the maximum height of 5.56 feet after 0.19 seconds. And I have now rounded to the nearest hundredth because that is what the question asked me to do. All right, that concludes today's lesson, Chapter 9, Lesson 4, Solving Quadratic Equations by Completing the Square.